Another huge challenge is mobility management. This is a new paradigm shift. Well, that's obviously because it is few hundred kilometers above you in the skies with several kilometers per second speed. There is no three-sector base station. There is no constant base station location. Yes, everything is in movements. Not only user equipment, but also infrastructure. We also should take into account the Earth rotation. Also, there are fast moving user equipment, aircrafts, drones, millions of different devices such as handheld devices, smartphones, IoT devices, very small attitude terminals such as VSAT antennas, yes, for example, Starlink user equipment, aircrafts, thousands of satellites with no natural hierarchy. Yes, this is another aspect of satellite, of space communication, that there is no hierarchy. There is no one main satellite and other secondary satellites. No, this is flat hierarchy. Very probably all satellites are the same. Yes, maybe there are some multi-layered structure with different attitudes. This is a different from cellular networks. And physical location of satellite is also not equal to logical topology of space networks. That's the question: how to perform addressing of information, how to perform networking, routing. Also, different type of connections could be possible. One UE to many satellites, or dual connectivity, connectivity with the ground-based station and satellite at the same time. And very probably it is going to be not only in the first standards of 3GPP, 5G standards, but in enhanced versions of 5G or even in 6G we will see the dual connectivity mode when UE could have simultaneous connection with satellite and with ground-based station. Of course, large cell radius, it is also a challenge. All of this results into frequent and massive handovers with massive signaling overload, with a lot of control layer signaling. As an example, LEO satellites, cells for LEO satellites, they move every several seconds in case of Earth moving cells. As a result, frequent handovers with moving cells lead to excessive signaling and high probability of handover drops. One of the possible solutions is to use new type of handovers, new logic for triggers for handovers. For example, very probably it is going to be conditional handover. When network send commands with a condition, location or RSRP based command, and UE execute when condition is met. This is basically conditional handover. Network instructs a UE to keep measuring location or signal strength and wait until condition is met. We will talk more about mobility procedures in 5G NTN in the next chapter with a lot of details. So not only new logic, new triggers for handovers are required, but also new radio resource management mechanisms are required. What about scheduling? What about load balancing? What about quality of service end-to-end support? What about interoperability with ground-based stations, with cellular networks? A lot of new challenges. And from networking point of view, there are also huge amount of issues. Multi-hop packet forwarding, scalable addressing, routing techniques, and so on and so on and so on. And of course, new changes in 5G and R interfaces are required to deal with delay variations, with very interesting handovers. We will talk about it with more details in the next chapter, so just stay tuned, wait, we will talk about it as well. And I want to say that each of these points is a huge area for research and for development, for standardization. If you're interested in that, please also take a look at my 6G course. Very probably some of that topic I will discuss with more detail, some of them related to 6G networks, to future networks. Not all issues is solved by today.